Good morning, everyone. Let's get started. First of all, our location for Sunday's class is going to be back in our original classroom upstairs. So we won't be using the computers on Sunday. Hopefully they've been still cleaning and dusting in there because it's been so long, you know. Just refresh your memory. It's upstairs. Anybody remember 214? Okay, thank you. So we'll be back there on Sunday, but then I think most likely back here again on Tuesday. So, yeah. All right. On Sunday, you're going to submit homework 9, which is rate of return, multiple alternatives, and the last question on that assignment covers an idea that we're going to introduce in class today, which is the analysis on an annual basis for increments. And then also, just to put that thought in the back of your mind, the project is eventually going to be due. It's due on the 17th of April, and the best strategy for being successful on that is just to try and break it up into pieces. Put in an hour here, an hour there. Don't try to do everything at once, or else you'll feel overwhelmed and the quality will suffer. If you can just work on it a little bit at a time, then that'll give you the chance to ask questions when you feel uncertain. Any questions related to these announcements before we get into the new stuff? All right. If you didn't already pick up your quiz, you can get that at the end of the class. It's just on the chair at the front of the classroom. All right. There is some terminology that we probably should take a look at because there's so many different ways the letter I is being used in the material that we've covered so far. And so let's just go through the terminology and refresh our understanding of what it all means. Now, where we started at the beginning of the semester was just by talking about the concept of interest in general and the idea that that's a fee you pay for the privilege of borrowing someone else's money. Or it's a return you hope to earn when you are investing your money into a company or into some sort of an investment vehicle. So I, capital I, it refers to the interest amount. And so that's the number of dirhams or the number of dollars or whatever the currency is amount that you're getting paid periodically. And when we express that in terms of per unit of time, that's when the interest becomes an interest rate. And so the way the text is referring to the interest rate is with a lowercase I. And of course we have nominal and effective. There are different ways for us to express the interest rate. It may be per year, per period, but just generally speaking, the lowercase I means the interest rate. Now, when we're talking about the rate of return, that has some specific assumptions in it that just the plain old interest rate doesn't carry. And so I star, when we're talking about the rate of return, that is when the return is balanced such that the inflows and the outflows of a cash flow diagram are in balance over the period of the investment. And specifically for the internal rate of return, we have an assumption that the earnings can be reinvested back into the project. Now, the other thing you need to keep in mind about the internal rate of return, besides that, is that the internal rate of return also is assuming that the project itself can, I've already talked about the investments being reinvested into the project. So the other landmine, of course, with the internal rate of return is that you can't have a negative rate of return. It can only be applied for alternatives that are generating a revenue. Next week, when we start talking about public projects, there are plenty of cases where the municipal government is making investments that don't necessarily generate returns. And so we have a different way of comparing alternatives instead of calculating IRR. The external rate of return is when we have some outside reinvestment rate. And so when the assumption isn't true for the internal rate of return, that the earnings can't be reinvested, then that's when we calculate the external rate of return. And in your textbook, the way that they're assigning a variable to that is with I prime. Now, just to ease your mind, I don't plan on a quiz or an exam to use these variables in a way that would stump you. I have no interest in saying I star equals and I prime equals and then you be left trying to remember which is which. I'll always use the name of it. So I'd refer to the external rate of return or the internal rate of return. So you don't have to stress about memorizing and distinguishing all of these variables, but the reason I present them is just to clarify, if some of you are continuing to follow along in the book, what some of the different uses are in the text, and also just because I think it's good to stand back and review what the terminology means, because we've got so many things thus far. Epsilon is how I've referred to the external reinvestment rate, just to try and at least have one variable that doesn't start with the letter I. But your book, it's referring to it as I with a subscript of I. So as if there's not enough, it's I sub I. And the external reinvestment rate, remember, if you have money that you can't put back into the investment, you're having to park it into a savings account or roll it into some other investment. That's what the external reinvestment rate is. So the external rate of return is sort of a weighted average. The external rate of return takes into account not only where you're putting the money, which is this external reinvestment rate, but the external rate of return also factors in the rate at which the cash flow itself is generated. So when you have a cash flow diagram, that sort of implies the pace that your investment is generating returns, but then where you put those returns once they're generated is the other part of the equation. So external rate of return has two pieces, and this external reinvestment rate is one of the two pieces. Finally, your text used the variable assignment delta I star for when you're doing incremental analysis. And I think this one's actually maybe one that's easy to keep straight, because the delta tells us that we're comparing the difference in investments. So last time when we met on Tuesday, we were sorting our alternatives from cheapest to most expensive, and the question we were asking over and over again is the extra amount worthwhile? Because we start by looking at the cheapest alternative, and if it gives us a rate of return that's greater than the MAR, then that's good, we accept that alternative. But then anytime you have to consider the more expensive alternative, you ask yourself, is it worthwhile to spend the extra amount? So for instance, if you're booking a hotel, you could book a really cheap hotel and spend hardly any money. Maybe it's small, maybe it's not very clean, maybe it's in a bad part of town. So when you look at the next most expensive hotel, if it's costing you an extra 200 dirhams per night, you should ask yourself, what are the differences between the two? And is that extra investment worthwhile? And so delta I star is looking at the difference in the initial investment and then the difference in revenue. And the criteria for that, just to review from what we talked about on Tuesday, is you try to beat your minimum acceptable rate of return. And so that if the delta I star is greater than the MAR, then you accept the next most expensive alternative. Now if you reject it, remember the clue when you reject an alternative is that you forget about it completely. When you continue to look at the next most expensive alternative, you'd compare it to the last one that was a yes. You don't compare the next most expensive alternative to something that you've already rejected. So, any questions related to this review of the terminology and the variables? All right, well, yes, in the back. If delta I star is greater than the MAR, then you accept spending the extra amount. But if it's less than the MAR, you reject spending the extra amount. And so if you have lots of alternatives you're comparing, let's say if you're comparing alternatives A, B, C, D, E, so you'd start off by doing B versus A. And let's say that the incremental investment gives you 12% and your MAR is 10%. So that means that B is your new favorite and you move on from A. But then let's say that when you're doing C versus B, that when you do the analysis, the delta I star is only 8%. So if your MAR is 10, that tells you that the extra amount isn't justified. So you reject this one and you keep B. And so then the next time when you're looking at option D, now we're going to be comparing D versus B, because B was our previous favorite. It's the last one that we said yes to. And so maybe now when we compare the increment, then it's 11%, and since our MAR is 10, then we say yes to this one and we forget about B. But then finally, if we're doing E versus D, and then the incremental return is only 7%, then we'd say no to E and we keep D. So we just order them in terms of cheapest initial outlay to most expensive initial outlay, and keep asking ourselves, is the additional investment worthwhile? Other questions? All right. So here's what we're doing today. Sometimes companies rent things rather than purchasing them outright. And when companies rent things or pay for them on an annual basis, sometimes it's more convenient for us to do our analysis on an annual basis instead of on a present worth basis, for instance. And so here's an illustration where a lot of times IT departments will purchase their software on an annual subscription basis rather than just a one-time licensing fee. And sometimes companies will lease office furniture or lease computers. And so if you're comparing the HP to the Lenovo, then what you'd want to do in an annual worth investment is you'd take any costs that are in the present or in the future, and you convert that into an annual expense. And then once you've found the annual expense, then you find the increment of the annual expense. And so just in terms of a cash flow diagram, remember that oftentimes what we'll have is some of the things will be an upfront cost. Sometimes we'll have annual maintenance and operation charges, and then we sell equipment. And so the essence of an annual worth analysis is you'd convert what's in the present to some annual expense, and you convert what's in the future to some annual expense. And so you've done the conversion, and now comparing alternatives, you'd look at how much more does option A cost compared to option B on an annual basis. And the decision point is the increment more or less than the MAR? So the MAR is, of course, most often related to how much we're paying to borrow money. And so if something about the HP makes you more productive, so it costs more, but it's allowing you to do more, then you're going to look at, is the additional productivity and the additional revenue worth how much extra that you have to pay? So there's a method that we're going to use in class exercise 24, and I want to, no, is today 24? Yeah, class 24, March 24th, on the 24th. All right. So here is the procedure that we're going to do. We're going to have a problem statement where you're going to have two options. And by the way, this method assumes the repeatability assumption. If you have a different number of if the useful lives are different, then you don't have to manually make any adjustments for the repeatability assumption. But just to remind you, when you're doing an annual worth calculation, you're assuming that if they have different useful lives, that at the end of those useful lives, you can go out and buy the equipment again for the same price, that you can renew the contract, whatever the case may be. So we're going to set up a spreadsheet that looks like this, and this is just my suggested template. You don't have to necessarily follow the same approach to get the right answer. Well, what we're going to do is we'll have some initial cost for both option A and option B, and so we're going to convert the initial cost into an annual amount. We haven't done that function very often. We've done the FV function, which takes something into the future. We've done the PV function, but do you remember what is the function that will take a present value or a future value into an annual amount? the function that will convert a present value into an annual amount. So remember, in our procedure, we're going to have, in this illustration, we're going to have something in year 0, which is our initial purchase price. We're going to have a future value, which is a salvage. How do we convert on the computer in an easy way? I mean, we can do it with the tables, right? But how do we use the computer? What's the function to convert something from the present value into an annual series? Converting it into a payment. That was a hint. The function is equals PMT. And so remember, when you start, I won't go through it all because I want you to get a crack at doing it on your own. But when you start typing in the payment function, PMT, it'll prompt you what it needs to see. It'll prompt you that first you need to put in the interest rate, first you need to put in the N value, and then PV or FV. So if you're working with a future value, then you skip over the PV field with 2 commas. But if you're working with the present value, then you just put in the present value and terminate the function. All right. Here's the thing, though. What you're trying to find out is you're trying to find out what is the rate of return on the difference between the alternatives. So you don't know the interest rate. See how the payment function, it's asking you for a rate. So the rate that you're going to solve for, this is an iterative process. Iterative means we can do things over and over and over again manually, or we can use our good friend GoalSeek to do it for us. And GoalSeek takes the tedium out of repetition. So down here, this difference field, I've put that in there because what you're going to try to do as your GoalSeek criteria is you want the difference in the sums of the annual worths to be equal to 0. So that's your goal. You're going to be playing around with this guess of the interest rate over and over until the two amounts are equal. And that tells you the rate of return on the increment between them. So we'll do the calculations, and then we'll come back to the theory of it, because sometimes it's not just enough to get the right answer. You have to understand what it means and how you got there. So you've got the paper there. Let me unlock the computers, and you can use the template I provided as a starting point. Okay, so here's our spreadsheet, and the first thing we do is just start with some guess. It doesn't matter what it is, unless it's such a crazy guess. Like if you said negative 99999, it may be so far away from the actual answer that it can't find it. So you have to give it some sort of a good starting point. Let's just say 1%. So I'm going to find use the payment function using this rate. N is 10. And this is a present value. Okay. And then I'll do the same function here. I'm just going to do Control-C and Control-V. Copy and paste, except for I need to move that over there. Okay. Payment. Forgot to put in the negative sign for this one. Okay, so we want to keep changing this guess interest rate. Let's see. There may still be 1, 2. It's getting good and close. 0.126. Right. So if I do GoalSeek, data, What if analysis, goal seek. Our objective is for this to be 0. All right, before I answer your individual questions, and I'll come circulate around, I wanted to explain what this means. So one of these alternatives is more expensive than the other. Option B is more expensive. So what we need to find out is, should we do option B, yes or no? And what we have in the problem statement, it says at the bottom of the page, our MAR is 9%. And so we want to find out, is the extra amount we would have to pay for B justifiable? And so here we can do the what if analysis. Did I already do it? Yeah, all right. Oh, not yet. Data, what if analysis, goal seek. Our objective is for this to be 0 by changing the interest rate. Okay, so 12.65%. So if we spend the extra amount, if we get option B instead of option A, it costs us more, but we're also reducing our expenses more. You know, this one, it looks like the real value is option B is cheaper on the annual basis. The annual costs for upkeep or maintenance, whatever it is, although option B costs more initially, you save so much money on the annual maintenance that it's worthwhile, because what we found out is that the incremental rate of return is 12.65%, which is higher than 9%. So our interpretation is that, yes, we should go for option B. Any questions just about the interpretation? All right. If you got 12.65% and you understand what I've just been talking about, then you're free to leave. But for those of you who are still working on it, I'll stay in the classroom and help you troubleshoot your spreadsheet. Be sure and save this, because you're probably going to want to have a copy of it as you're working on the homework. All right? You too. Here's the proof that the internal rate of return increment is 12.65%. You just make the cash flow diagram the old standard way.